Let's start. Okay, let it now. See here, Huffman coding. Okay, now. So what is this Huffman coding is nothing but, I will tell you, it has one more name. Okay, one more name. I will tell you later. Even many teachers don't know that. I will tell you, don't worry. Okay. What is this exactly? Huffman coding is nothing but, think like that. One big message is there. Okay, something you will going to send a message to your friends, right? Something like hi, good night, how are you, like that. How it will going to receive to the receiver. Suppose example, I will take here for example. Aish is sending message to Jitu saying that Aish will say, had your dinner. So Jitu will going to receive, had your dinner, like that. See, Ayush is the sender here. Again, Jitu is the receiver. Whatever the message Ayush sent from his device, it has to be reached to Jitu's. Okay, but message should not be changed. Okay, now message should not be changed. And one more important thing in this, one more important thing is basically, so whatever the message you wanted to send, for that message, we will going to allocate some space. Okay, I will tell you how much space you will going to allocate all those things. Okay, we will going to allocate some space. It will take that space in server and it will going to send it to the receiver. Okay, that is what exactly it will going to happen. Now see here, I will consider there is a message M. Please understand, there is a message M. Okay, this is a message. I will write like this. That is better actually. Please concentrate. This is very, very important actually. There is a message. There is a message M. I will represent using M. Okay. And which contains here, there is a message M which contain 100 characters. 100 characters. Okay, na? Which contains 100 characters with some distinct characters, with some distinct characters. I will tell you what is it. Nothing but identified characters. Okay, I will tell you. So here, and characters, 100 characters are there. Nothing but, suppose think like that is what I told you. One big message they are sending. Think like that. Here is a sender. Consider Ayush. Okay. Here is the receiver. That is Jitu. Okay, now. So from here to here we are sending message. Okay. Here to here we are sending. Some message you are sending, it has to reach to here. Now, what I'm saying here, maybe that message consists of 100 characters. I don't know what is that message. Okay, it is left to you. It consists of 100 characters. That is the reason why I have given this one. Now, in that message, please here, that is what we call it as, there is a one message M like this. Okay, now again, in that 100 characters, A is repeating 45 times. Clear? Again, C is repeating 3 times. Again, B is repeating something like 1 time. D is repeating something like 20 times. Again, E is repeating something like 30 times. Again, F is repeating something like 1 time. Okay. So what I said, distinct character is nothing but in that message. So this guy is sending some message. In that message, these are the alphabets which are available. These alphabets are repeated in 100 characters. That's why it is called it as distinct characters. Okay, 100 may repeated in 45 times. B is repeated in 1 time. C 3 times. D 20 times. E 30. F 1 time. That is what exactly. Now I will call this 45. I will call this 45. What is that? A's frequency. A frequency. A frequency. Okay, na? A frequency how much? That is 45. Nothing but what? A repeated 45 times. B frequency is what? 1. C frequency is what? 3. Like that. Okay, na? How you will going to transfer here? How you will going to transfer? Using transfer media. Okay, that is what you people are studying in. What is that? Data communication. Data communication. This is what exactly you people are studying. How you are going to send the data from one node to another node. Okay, so using bits, understanding using bits. That is what you are going to study about data communication. Okay, it's okay, fine. Now tell me. Now please understand everybody. Suppose this is one message we are sending. This is one message we are sending to this particular person. Now to send this one, please understand, to send this, okay, message to the person, it is taking 8 bits. Okay, when I want to represent A, okay, 45 number, it occupies basically 8 bits. I will tell you what is this 8 bits, all those things, don't worry right now. Okay, suppose think like that, for that one particular, this one A, it is taking 8 bits of memory it is allocating. Again for B, it is taking 8 bits. C, it is taking 8 bits, like that. For each and every character, here, for each and every character, I will write also. See, A, how much it is taking? 45 times it is running. Okay, 45 times it is running into here 8 bits. Okay, na? Again B, that is equal to, okay, 1. Okay, how many times it is repeating? 1 time. Frequency is 1 into 8 bits. Why 8 bits? You can ask me why 8 bits, sir. Basically, it's a ASCII value. ASCII value represents using 8 bits. ASCII value, ACII, ASCII value for each character. Please here, for each character. See, suppose think like that, A is a character. How many byte it will going to take? 1 byte. Yes or not? 1 byte. 1 byte it will take. So I wanted to represent this character using ASCII value. Using this ASCII value. Okay. So that is the reason why it takes 8 bits. 8 bit is nothing but what? 1 byte, right? 8 bit is nothing but what? 1 byte, right? That is the reason why 8 bits. 8 bits. Understood now? Why I am taking A 45 into A? For E to represent each character. How many bytes it required? 8 bits. 8 bits it's required. Clear? Everybody clear? Up to here clear? You should not get any doubt at all, first of all, when I'm explaining. Okay, why I am writing 8 here? Because the reason is, suppose if you want to represent a, how much bytes you required? 1 byte is required. 1 byte is nothing but what? 8 bits. Correct or not? 1 byte is nothing but what? 8 bits. Correct? That's why 45 times it is running, 45 times it is repeating into 8. Okay, again B is repeating, frequency is 1 into 8. Again C, how many times? 3 into 8. Okay, na? Again D, how many times? That is equal to 20 into 8. Okay, na? Again E is equal to 30 into 8. Okay, na? F is equal to 1 into 8. Understood everyone? See, 45 times we are providing 8 bits. 45 times we are providing 8 bits. Understanding? Total, see, total how many bits you are providing for this particular characters? A, B, C, D, E, F. Okay, totally how many bits you people are providing? For 100 characters, that is what is Aish is sending 100 character message to Jitu. 100 character message to Jitu. I don't know what is that message. Don't ask me. Okay. Then 100 characters is going here in that repeating frequency of nothing but this is the message, right? This is in this message distinct characters A, B, C, D, E, F. Those A, B, C, Ds are running 45 times. This one A, B, C, D, E, F like this. Okay. For each and every character, I am providing 88 bits. 88 bits for 100 characters. So totally, if you do totally, how many bits it will be? Totally 800 bits. Okay, for 100 characters, it is taking around 800 bits. Yes or no? 800 bits. If you want to calculate 1 into 88, you will want to get it 24 like that. You will want to get totally 800 bits. You will want to get it. Yes or no? Okay, that is fine. For 100 characters here, for 100 characters, he is sending a message. Yes or no? This guy is sending a message. I don't know the message. This guy is sending the message. Okay, to this person. So that size is 100 characters. That size is 100 characters. For that particular size, these many bytes it is taking. These many bytes it is taking. Clear? These many bytes it is taking. Okay, now. So if you are able to 100, if you are able to understand this one, nothing but what exactly I'm talking here, these many bytes are required. These many bytes are required to send the message from ear to ear using what? Media, some media. Okay, from ear to ear, I'm sending a message. Okay, this person is sending a message to this person. To receive, to send this message, how many bits is required? Totally 800 bits are required to reach this particular destination. Okay, understanding everyone? Okay, done. I think you people are very clear. Okay, for 100 characters, we are getting 800 bits. What about for one character, sir? Very simple. How to calculate that? For one character, see here, for one character. So what do you have to do? 800 bits. Okay, divide by 100. Okay, na 100. How much you will going to get it? So cancel, cancel. Okay, 8 bits. Correct? 8 bits it is taking. Fine. Got it now? For each one character, it is taking 8 bit, nothing but 8 into 45. That is the story I given to you people right now. Again, finally, see here, finally, everybody. Average transferring rate is what? Average transferring rate, that is equal to, what is that? 8 bit. 8 bit. Okay, average transferring rate is totally 8 bit. So this one, so this is the story. Understood? To send a message from here to here, this much bits it is taking. Okay, for one character, how much bits it is taking? 8 bits it is taking. For 100 characters, 800 bits it is taking. So why I am using ASCII value? Because so character takes how many bits? How many byte? 1 byte. Okay, character takes 1 byte. 1 byte is nothing but what? 8 bits. 1 byte is nothing but what? 8 bits. So that is the reason why I taken 8 bits, because of representation. Okay, sir, I understood everything. No problem, sir, about this. I given very clearly about this. Okay. One character is good. Okay, 1 byte. Okay, I given very detailed one. Now tell here. Now see here, everybody. I will go to the next page. Okay, now what we got it totally we got 800 bits. Everybody please observe and be careful, be aware. Okay, awareness please. Now see here, everybody, 800 bits we got it. Yes or not? 800 bits we got it. 800 bits we got it. To send a 100 character. Yes or not? To send a 100 character. 100 character data I am sending required is 800 bits. Okay. 100 sending, here receiving. 800 bits it is required. Fine. Now my question is, please understand what is my question. Sir, can I compress these many bits? Why should I utilize 800 bits? Is it possible to compress? That's the question. Is it 800 bits? See here, 800 bits. 800 bits we have right now. Yes or not? 800 bits it is taking to transfer from one node to another node. Okay. Now, can I able to compress this 800 bits? Can we compress? Can we compress? So this is the question. Okay, this is the question. Yes or no? This is the question. Now my answer is, please here, my answer is, everybody observe here. What is my answer? Yes. Yes. How? Using Huffman coding. Using Huffman coding. That's it. That is the reason why we use the Huffman coding. Understood? Everybody got it now? Everybody got it? This is the beautiful concept. Using Huffman coding. Yes or not? I will tell you, but still I will going to say one more important thing is there. Still I will going to tell you. I am little bit urgent here. Still have a lot of things to say. See here, observe here. Okay, 800 bits. Okay, okay. To represent 800 bits, we need a 8 bits. Please here, go back here. To represent all these uh, distinct characters, we need 8 bits based on ASCII value. But what I will going to do, I will going to use the 3 bits instead of 8 bits. Sir, why you want to use the 3 bits here? There is a combination. Please observe here. Now everybody observe here. So there is a combination. I can able to see here 800 bits is there. Please understand this line. 800 bits is there. Still I can able to compress here. Everybody observe here. Still I can able to compress here. How? A. Okay, how many times it is repeating? 45 times. Yes or not? How many times it is repeating? 45 times. I will going to give the 3 bits for this. 3 bits. Instead of giving 8 bits, I will going to give the 3 bits. Sir, why you are doing like that? I will tell you. Don't worry. So B, how many times it is repeating? 1 time. For that also, I will going to give 3 bits. Again, C, how many times it is repeating? 3 times. Now for that also, I will give 3 bits. Again, for D, how many times it is repeating? 20 times. For that also, I will going to give 3. Okay. Okay. Fine. Again, E. Okay. For that also, how many times it is repeating? 30. I will going to give 3 bits. F. How many times? 1 time. For that also, I will give 3. Okay, now. Now, if you do this one, okay, if you do this one, what happens? Can we reduce this? 300 something, we will going to get it here. Yes or not? Why I am using 3 bits? Now come to the point here. Okay, now come to the point here. Everybody's here. Now come to the point. Why I am using 3 bits? 3 bits is nothing but, see here everybody, 3 bits is nothing but like this. Yes or not? Okay, 2 bits is nothing but like this. Yes or not? 8 bit is nothing but what? 4 this side, like this, sideways. 4 again, 1 2 3 4. Yes or not? If you go for 8 bits, you will going to get the big combination or not? 1 bit for this. Now, please observe everyone here. Please observe everyone. 1 bit means how many combinations you will going to get it. Here 1 bit I am talking about. 1 bit. 1 bit means how many combinations you will get it. Either you can store 0 here. Either you can store 0 or 1. 2 combinations. Correct? 2 combinations. Yes or not? Yes or not, guys? Again, if I take 2 bits, like this, if I take 2 bits, how many combinations you will going to get it? How many combinations? 4 possible combinations. Yes or not? 0 0 0 1 1 0 1 1. These are the 4 combinations I will going to get it. Yes or not? This is 4. 4 combination. If I take 3, see here, if I take 3, how many combinations you will going to get it? Totally, I will going to get the 8 combinations. Yes or not? If I take 3 like this, 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. You will going to get the 8 combinations or not? So that is the reason why 8 combinations I will going to get. Okay, to represent this one, okay, A, this is more than enough. 3 bits are more than enough. Yes or not? 3 bits are more than enough. Why should I waste that much of memory? Yes or not? 3 bits are more than enough. To represent 6 distinct elements here, 6 distinct character, 3 bits are more than enough for this. Why should I waste 8 bits of memory? So that what happens here, please understand, so that what happens here, it will going to be compressed or not here? It will going to be compressed or not? Okay, for example, take it. Now, I think you people got this one bit. Again, this is for 2 bit. Again, this is for 3 bit. Okay, so you got the 8 combinations. Now what I will going to do for A, please observe here, for A, everybody please observe, for A, I will going to give my own code, something like 000. For B, I will going to give my own code, something like 001. For C, I will going to give something my own code, 010. Okay, D, I will going to give you something my own code, 011. Okay, now for this also I will give you my own code, 100. Again for F, I will going to give something different code, 101. Nothing but 0 is nothing but what? Basically, it's a 0. This is 1. This is 2. This is 3. This is 4. This is 5. There are 6 characters are there. I given different code for each and every character. That is the reason why I am using 3 bit, because I am getting more combination, 8 combinations I am getting. In that I am using only 6. In that I am using only 6. Yes or not? Now you people agree? Now you people are okay. Now you people are okay. This is very important concept. So if you are able to understand, okay. So now if you calculate this one, it will reduce to 300. It will reduce to 300 bits. Calculate this one, you will going to get 300 bits here. Where is 800? Where is 300? We reduced or not? Where is 800? Where is 300? We reduced or not? Now you people understood, right? Now you people are understood, right? So now if you are able to compress this data this much, now the point is you can able to compress the data this much. Still I am asking, okay, still I am asking, see here, this is the point here. Still I am asking, can you compress further? Can you compress further? Can you compress further? This is the question now. See, inch before it was 800. Okay, inch before it was 800. 800 bits for 100 characters. Yes or not? But for same 100 characters, now I am using 300 bits. Now I am using 300 bits. Is this good or not? So really good. But still, computer science have a beautiful algorithm so that it will say that, can you compress further this one? Can you compress further this one? Okay. Now, still compression possible? One more question. Still compression possible? Still compression possible? Check. For that answer, for this question, please hear, for this question, there is an answer. Yes. There is an answer. Yes. Understood? There is an answer. Yes. Okay. This I said yes. Why? Because the reason is we have one technique. Please hear. Very important one, this one. So I said yes because the reason I said yes, because the reason there is an algorithm. There is an algorithm. There is an algorithm. Okay. What is that algorithm? Now that algorithm having a technique. Okay. This kind of techniques here, this technique This technique, okay, this technique is called as Huffman coding. Huffman coding. Wait. Huffman coding. Okay, now understood everyone? Got it now? Everybody got it? This much I compress 300 bits. Okay, 300 bits totally. So hence before it was 800. I compressed to 300 bits. Still I'm asking, okay, can I able to compress? Yes. So that is the reason why that kind of technique we will call it as what? Huffman coding. Here, this is Huffman coding. Okay. Okay. Nothing but what exactly? It means nothing but what exactly it means. Every character will going to get the code. Nothing but giving code to every character. Okay, code to every character. Code to every character. That is what exactly I did here. You can see. Okay. So this is also called it as finally. This is also called it as data. This is also called it as data encoding and data compression technique. So this is what exactly. Okay, this is what exactly. That is the reason why. See, everybody observe here. That is the reason. That is the one reason. That is the one reason this Huffman coding have a different name. Please see here. This Huffman coding have a different name. Nobody knows this. Okay. See here. So that one we will call it as optimal optimal prefix notation. Okay, Huffman coding you can call it as optimal prefix notation. I will tell you. Everybody clear? Up to here, everybody clear? Up to here, everybody clear? Still haven't started anything. Please understand. Still haven't started anything. Just I said how to compress the data. Okay. Now, I think everybody understood. We will going to start now. We will going to start now. I think everybody understood now. Now see here. Now what we're going to do? We're going to start here. Treating same for each character, even though character repeats. Okay. So I will going to tell you what is this exactly. No need to worry at all. Here, Hoffman will going to behave like something personal office. Okay. I will going to tell you what is this personal office. All those things. Don't worry. Here, what I will going to do? I will going to take one small example. Okay. After I will going to take a small example. Let's see that example. After that, we will going to understand. Everybody, I will tell you in example. I will tell you. Let's see the implementation now. Implementation. Okay, now we will see the implementation. Okay. Just a moment, guys.